Let's move to wave speed. Wave speed of a progressive wave. The wave speed of a progressive wave is defined as the speed at which the waves transfers energy. The wave speed of a progressive wave is the speed at which the wave transfers energy. So, for example, we said that the speed of sound is 340. The speed of sound is approximately 340 meters per second. This means that the speed at which sound transfers energy is 340 meters per second. If you say that the speed of light is 3.0 times 10 to the power 8 meters per second, this means that the speed at which light transfers energy, which is light energy, is at the speed of 3.0 times 10 to the 8 meters per second. So the speed of a progressive wave is the speed at which the wave transfers what? Energy. Now, since you know that the wave is moving at a constant speed, so we can say that the speed will be the distance covered over time. So I can say that the speed v is distance covered x over time. When the wave completes a quarter of a cycle, for 1 quarter cycle or oscillation, distance covered x will be 1 quarter of a wavelength. For half cycle, distance covered will be half wavelength. For 1 full oscillation, distance covered will be 1 wavelength. Distance covered will be 1 wavelength. So I can say that for n number of cycles, distance covered will just be what? N wavelengths. So I can say that the wave speed will be, distance covered will be n wavelength over t. And you can recall that number of oscillations completed per unit time is the frequency. Therefore, the wave speed will be given as what? F lambda. F is frequency, lambda is wavelength. Or I can say that when the number of cycles or oscillation completed is 1, the time taken to do that is the period. So from here, V becomes 1 wavelength covered in a time of period. Okay? So V is wave speed, lambda is wavelength, P is period, F is frequency. Okay. Okay. So very quickly, so remember this. So very quickly, let's look at wave intensity. Let's look at wave intensity. Symbol for wave intensity is R. Intensity is defined as the energy transmitted or energy transferred per unit time per unit area. So intensity is defined as energy transmitted per unit time per unit area, that is intensity, is defined as energy transmitted per unit time per unit area. So intensity I is energy transmitted per unit time per unit area. And you can recall that energy transmitted per unit time is known as what? Power. So the wave intensity can be defined as power transmitted per unit area. So this is also measured in watts per meter square, where this is measured in joules per seconds per meter square. So intensity is also defined. Intensity is also defined as power transmitted per unit area. Alright. So these are the two ways we define intensity of a wave. So if a wave is well intense, you have a lot of energy going to a small cross-sectional area. Now, intensity is synonymous to loudness. Intensity is synonymous to loudness. So what are the factors affecting intensities? So let's look at that. Factors affecting intensity. Factors affecting intensity. Factors affecting intensity. Factors affecting intensity. Number one is amplitude. Remember, we have said that we can denote amplitude with A. One of the factors that affect intensity is amplitude, denoted with A. Now, how does amplitude affect intensity? If you are playing music from a loudspeaker, you now increase the loudness. When you increase the loudness, you see that the amplitude of vibration of the cone will increase. So if they were made vibrating like this before, the cone vibrates more, amplitude increase. Boom, boom, boom. So when you increase amplitude of vibration, loudness increases. Or if I'm playing a drum like this, and I increase to this, I have increased the amplitude, which is the maximum displacement from the equilibrium position, compared to this. So as you increase amplitude, intensity increases. So intensity is proportional to the amplitude squared. Intensity is proportional to amplitude squared. So intensity I is proportional to amplitude squared. So if the amplitude of the wave is doubled, the intensity will increase by square of double. That means the intensity will quadruple. If amplitude is tripled, intensity will increase by a factor of 9. If amplitude is quadrupled, that means the amplitude is increased by a factor of 4. Intensity will increase by 4 squared, which is 16. So intensity is proportional to amplitude squared. So I can write it like this. Intensity is equal to constant multiplied by amplitude squared. So I over amplitude squared is what? Constant. So I can say that I over amplitude squared initially will be equal to intensity over amplitude squared in the new case. So I can write it as initial amplitude over the new, the initial intensity over the new intensity will be equal to the initial amplitude over the new amplitude or squared. Okay? Question. The intensity of a wave is I. If the intensity is doubled, by what factor will its amplitude change? By what factor will its amplitude change? Question mark. So we are told that the intensity of a wave originally is I. The intensity of a wave originally is I. The intensity is now doubled to 2I. The intensity of a wave originally is I. The intensity is then doubled to 2I. By what factor would the amplitude change? Let us say the initial amplitude is A. We don't know the new amplitude. Let's call it X. All squared. I takes I. So I have 1 over 2 is equal to what? A over X all squared. I'm solving for X. What do? I take the square across the cosine. When you take square across the cosine, it becomes square root. So that becomes 1 over square root of 2. Because the square root of 1 is 1, the square root of 2 will be root 2. Is equal to what? A over what? X. Therefore, the new amplitude, if we cross multiply, the new amplitude will be what? Root 2 multiplied by the initial amplitude. So the new amplitude will be root 2 multiplied by the initial what? Amplitude. So if the intensity of the wave is doubled, the amplitude will increase by a factor of root 2 using this mathematical relationship. I may not even need to solve it like this if you know relationship. So here, what do I mean? Here we have said that intensity is proportional to amplitude squared. Therefore, I can say that amplitude is proportional to the root of intensity. See that? Intensity is proportional to amplitude squared. So I can say that amplitude is proportional to the root of what? Intensity. You take the square across the cosine and it becomes square root. So if the intensity is doubled, meaning that intensity is increased by a factor of 2, amplitude will now increase by a factor of root 2. Because amplitude is proportional to the square root of intensity. If you reverse this is what I mean. Amplitude is now proportional to square root of intensity. If it is proportional to amplitude squared, the amplitude is proportional to square root of intensity. So if the intensity is doubled, that means the amplitude will now increase by a factor of root 2, which is what we are saying here. So I don't need to solve it. So I can say that if the initial amplitude is A, if the intensity is now doubled, then the amplitude will now increase. The new amplitude will now increase by a factor of root 2. Okay? The second property that affects intensity is frequency. Frequency F. How does frequency affect intensity? Also, intensity is proportional to frequency squared. So in the same way, I can say that intensity is proportional to frequency squared. So I is equal to what? K F squared. I over F squared is equal to K. So I can write it there, say I over F squared initially will be equal to what? I over F squared in the second case. So that I1 over I2, if you cross multiply, will be equal to what? F1 over F2 all squared. So that is the way intensity is also affected by frequency.